Online. Hi, everybody. Welcome. I am going to start sharing some stuff here for you. Thanks for all of you joining early to get kind of an update on USP TR369 before we start the main webinar. So my name is Jason Walls from QA Cafe, and I am the director of technical marketing at QA Cafe, but I'm also the one of the co-directors of the Broadband User Services work area at the Broadband Forum. And that is the group that produces TR69 and the data models and USP. So the reason why I wanted to give people a primer on USP is because not necessarily people have heard of it. Jeff is gonna go, when we get to the main webinar, he's gonna get into how to ask questions and participate in the webinar. We might do a couple of polls and stuff like that. So if you do have questions, you can type them into the Q&A box. And I see somebody has already asked, will the presentation be made available after the call? And yes, of course, we will absolutely be making that available, and the video of this webinar will be available. So let me get started on this. So I wanted to assume that, actually, maybe I can do this. Why don't I? Oh, you already have a poll there. Okay, it's fine. I'm assuming that people have at least some familiarity with TR69. If not, I'm going to go through the history of how we got here really quickly, just so people understand what it is that we're talking about. So back in 2004, ISPs saw a need to do this lifecycle management of their CPE. There wasn't really a good way to do it. They were relying on either sending people out to a house or using CDs, remember that? And relying on some other technologies. But so what they did is they got together the Broadband Forum, and they gave birth to TR69, or CWMP, which is the CPE WAN Management Protocol. And then over that time, we added more stuff. So TR69 at the time was a combination of the protocol itself and what we call a data model, which is a description of the devices and how you describe devices and how you describe their capabilities and the ability to manipulate them. And so over time, initially we were just modeling gateways, and then we started modeling things like set-top boxes and voice over IP functionality and Wi-Fi interfaces. And when we started doing Wi-Fi interfaces and getting into IPv6, we realized that it was the time had come to build a new version of the data model, and that gave birth to TR181 Device 2. And Device 2 ended up getting adopted by cable and MSO providers using TR69 for their more advanced gateways and for managing Wi-Fi. And then after that, we saw this explosion of devices over the last 15 years or so. And now we're in a situation where there really is just an order of magnitude more things. And on top of that, providers are in a position where they really need to be able to monetize the connected home so that they can find new revenue streams. And so this sort of perfect storm of the explosion of new devices, the need for providers to come up with new sources of revenue and provide and work with third parties and provide new services, on top of the fact that new technologies existed to make TR69 more efficient, we decided in 2018 to release. We started working like 2016. We started entertaining this idea of developing the user services platform. And then in 2018, we launched 1.0. And since that time, we have released 1.1. And that is really, really starting to lay the groundwork. I mean, it's out there. There's an open source agent that we're working with too, kind of unifying the best of standardization and open source to provide a solution that for ISPs to be able to do analytics and customer self-care and really standardized managed Wi-Fi, standardized IoT. That's the stuff that we'll be talking about in the webinar today. So what is the user services platform? We say it this way: it's a system of controllers and agents that enables the remote manipulation of software and hardware capabilities. And what does that mean? That allows a lot of things like managed Wi-Fi, network AI and analytics, building a customer self-care application that the customer can use on their phone, building an actual app-enabled smart gateway, kind of opening that up to third-party services. We definitely have that on the Wi-Fi side. We have that on the security side. building an actual true interoperable smart home is possible with the things that we're doing. And one of the things that we wanted to make sure that we did was make sure that it was backwards compatible with TR69 and the existing data model, and that it could coexist. So providers out there who have huge investments in their TR69 deployments can work with their vendors to make sure that they're able to migrate safely without having to completely overhaul everything and rely on the same data model that exists now that might already be tied into OSS or BSS systems. So we wanted to make sure that it could coexist, have a clear migration path, and be backwards compatible. And we say that it's flexible, scalable, secure, and standardized. And those were the design methodologies that we had in place when we went to start making it. So how does it work? So basically, an agent exposes capabilities to one or more controllers, and it can represent those capabilities that are on a device directly, but it also has a more advanced proxy mechanism, such that an agent can represent devices that aren't necessarily on the device that is being managed. So you might have Zigbee and Z-Wave devices, or through some other technology, or even just, a device that doesn't talk USP that can be modeled and represented by the agent. For controllers, the possibilities are endless because we have this multi-controller environment now. So it's not this one-to-one relationship between one ACS and one device. You can have controllers that do all kinds of things. So you can have a traditional ACS, you can have an actual controller that is either a portal on the cloud or on the gateway or on a smartphone, or you can build it into like a smart hub and have it act as an automated system. And what this does is really enable the entire ecosystem to work together. And it's kind of revolutionary. We say it's evolutionary because we wanted to go off the path of TR69, but it is a very powerful and new idea. And the things that enable that are some of the efficiency improvements, like persistent connections. In order to enable this multi-controller environment, we make sure that there's a clear trust establishment between the agent and the controller. You can, if you're crossing network boundaries, or you are, working with a transport like MQTT or Stomp, and you want to make sure that it's secure end to end. There's an ability to do end-to-end application layer TLS. When different controllers access the data model, there's rule-based access control to make sure they only see and only talk to the things that they're allowed to talk to. And that can be manipulated via the data model so that it can be turned on and turned off and changed depending on what the customer's permission levels are and what the service levels are. And one of the biggest things is that we've built it so that the transport, we call them MTPs, or message transfer protocols, to differentiate from the actual OSI transport layer. But when we talk about that, we're talking about things like CoAP, MQTT, Stomp, and WebSockets. And we built it so that the lines are clearly drawn so that it's very easy to add different MTPs or have them for different use cases. And that's the reasons why the ones that exist are in there. But the design is flexible such that we have transport that can be in the cloud and is designed for that, so that you don't have to worry about crossing firewalls and NATs. And then we also have transports that don't have to be cloud independent, so that you could run something that needs to be very quick in real time in the end user's home. You can see here, we kind of have a big diagram of how this all works. You can have multiple controllers in multiple places doing multiple things that are all talking USP to any number of agents. The other thing I do want to point out here is that we do have some out-of-band mechanisms for data collection too. So you can set up via bulk data collection this sort of massive polling mechanism of the information that you want and send it to a specific thing, to a specific server that is meant to collect that data. You can do that over USP, or you can do it over the HTTP bulk data mechanism. And then the real power behind all of this is the data model. And that's what we're going to talk about today on the main webinar. But the stuff that we've added to TR-181, specifically to enable things like USP, include the IoT stuff that we're going to talk about today, the ability to do that bulk data telemetry, and then all of the other things that you might be familiar with that are capable of being manipulated via TR69 today. But if not, you can see kind of a list of them down there. Doing initial onboarding, managing software containers. So you like managing a smart gateway that has virtualized applications on it, and doing firmware and software upgrades like you always could, and various diagnostic commands. This is just kind of an overview of the protocol stack, just for those people who are wondering how it works. So we have the USP messages, and those are encoded using protocol buffers to make them very efficient on the wire. And also it allows us to have a schema on both ends so that the information is standardized and both ends know how to interpret the data, which is something that is a little bit more difficult to do with some other technologies without doing it explicitly. That is then encapsulated in a USP record, and that's what handles all of the security and integrity and transport. And that's also a protobuf encoded. At that point, you might have an optional session context that's over TLS. That's that application layer TLS we're talking about. And then it gets transported over one or more message transport protocols. And the way that this has been designed, if there's a new use case that comes along that is beyond one of the MTPs that we've already designed, we included these for different reasons, right? So CoAP is for local transport, STOMP and MQTT is for when you want to use a message broker. We added MQTT in 1.1 because people asked, and it was very easy to add because we had drawn the lines very clear. And then WebSockets for those legacy CPE deployments that are probably migrating from TR69. Then obviously you can still have your transport layer TLS and running over the usual technologies after that. Okay, I mean, that is a quick summary of USP. Here's some resources that we put together. You can find the entire thing on usp.technology. Look for a certification coming soon, but there you can find the specification, you can find the protocol buffer schemas, you can find the data model, and you can find the test cases. You can find the open source USP agent that John Blackford, who is in the middle of joining right now, is spearheading, and that's an ongoing project through the Broadband Forum to kind of unify the best of standards and the best of open source, and so that's improving every day. I think they're going to be on the third release in a little while. At QA Cafe, we have, in addition to being the official test tool, we have a lot of training resources there on learning more about USP and how it works. And we're adding to that every day. It's kind of an ongoing process. We have the test tool with an automated and scriptable controller. There's a white paper that really goes in depth into the entire USP story and the use cases, and you can find that on the Broadband Forum website. It's MU461. And we ask that you join the Broadband Forum and get involved however you can. There's different ways you can get involved. You can get involved with the open source project without becoming a full member. You can definitely participate. If you see something that you want added to the way that USP works or something that you want clarification on, please, by all means, reach out to us and reach out to Jeff and Rhonda at the Broadband Forum to join and participate, because we love making standards with people, and we have a lot of fun doing it. And above all, so we also have launched this marketing arm called the Connected Home Council, and that allows people to promote their solutions that might be implementing these things. So this webinar that you are about to participate in was done through the Connected Home Council, and that's why we have this collection of companies here today ready to talk about TR181 with managed Wi-Fi, standardized IoT, new packet capture diagnostics, and how it all works and how some of our products implement those things. All right. So now, what do you want to do, Jeff? Do you want to just take a little short break and we'll start?
Yeah, well, I was thinking I love that we love making standards with people, Jason. I think we should use that as our tagline going forward.
It's the most fun you will ever have in standards, which is
anyway. Well, I want to just thank you, Jason. For those of you who are actually joining and are surprised to hear something going on right now,